Hello dear students, in this video we're gonna continue the first lesson, the light energy. Last time we have talked about the first property of the light, which was transmitting the light through different materials, and we've known that we have three types of materials: transparent, translucent, and opaque. Today we will talk about the second property of the light, which is light travels in straight lines. But first, what's the meaning of travel? Travel means propagate, and propagate means move in all directions. Look at this picture in front of you. You can see the rays of the sunlight propagate or moves in all directions, and you can notice that these rays travels in straight lines. But what the meaning of straight? If you look here, you can see that this beam of the light moves in straight line or direct line. That's meant by straight. Straight means direct. So, light travels in straight lines. I want you to choose from 1, 2, or 3 the word straight. Which one from these represents the word straight? Super! Number 1 is straight line. Now we will make an experiment to prove that light travels in straight line. Bring any 3 partitions or 3 barriers. Each one has a hole in the middle. Put them in the same line or in straight line. Light up a candle from one side and try to look from the hole from the other side. What will you see? Super! You can see the flame of the candle clearly. Try to do the same experiment, but move the second barrier a little bit to the left side. What will you see? You can't see the flame candle in this case? No. Why? Because the flame of the candle or the beam of the light moved from the candle to the partition C. Then it didn't find any other opening to move through because light travels in straight line. That's why we can't see the flame of the candle in the second case. Now, watch this video to make it clear.
OP34 to show that light travels in straight lines. We will use as apparatus 3 metal rectangles with holes, 3 wooden holders, some wire, and a laser. Method. When the 3 holes are in a straight line, the light travels through. We can check that they are in a straight line by stretching the wire to make sure it's straight. When the holes are not in line, the light does not travel through.
Okay. As a result of traveling light in straight lines in all directions, two phenomena happens. Okay, what's meant by phenomenon? Phenomenon means an incident happens in nature. And these phenomena are: first one, formation of pictures through narrow holes or pinholes. B. Formation of shadow. I will talk about each one in details right now, but first look at this picture. You know who is this man? Yep, super! You have a great memory. He is Al-Hassan ibn Al-Haytham. Okay, I will tell you a funny story about Al-Hassan ibn Al-Haytham to understand the first phenomenon, which is formation of pictures through narrow holes. Do you like stories? Well, you will like this one. Once upon a time, there was a man who had a great mind. He liked to explore everything around him, especially the light. He noticed one day, when he was sitting in a closed room, that there is an image of inverted mosque, and by the way, the word inverted means upside down. So he found this image of inverted mosque was formed on the wall in front of him. He started to think about this incident and asked himself, how was this picture formed? Then he got the answer. He found that this room was closed from all sides and found that light enters through a small hole on the wall in a straight line and formed this image on the opposite side of the hole. This image was inverted and minimized, and I said before that inverted means upside down. You can see clearly here that the image of the mosque is inverted or upside down. Also, it's minimized or small. From here, he concluded that the images that formed through narrow holes or pinholes are always inverted and minimized. And this phenomenon happens because light travels in straight. And this is the idea of photographic camera. If there is any closed box which has a pinhole like this picture in front of you, it allows light to pass through it to form an image, and this image is inverted and minimized. You can see the image of the tree. It's very small and it's upside down on the opposite side of the hole. And in the camera, if we replace the opposite side of the hole with a film, we can capture a photo, or the photo can be taken. Watch this video to make it clear.
The pinhole camera consists of a box with a small hole in a metal plate at one end and a screen of tracing paper or frosted glass at the other end. If the camera is pointed towards a tree, an inverted, diminished image of the tree is formed on the screen. As shown here, light rays from the top of the tree A travel in a straight line and fall at X on the screen. Rays from the bottom of the tree B fall at Y. Thus, XY is the diminished, inverted image of the tree on the screen. If the hole is larger than a pinhole, the image obtained will be blurred. If the screen is replaced by a photographic film, a photograph of the tree can be taken. Increasing the number of holes increases the number of images.
Okay, now complete. The image is formed through narrow holes is A and A. Yes, inverted and minimized. Super. Okay, give reason. Formation of images through narrow holes. This phenomenon happens because of what? Yeah, because light travels in straight line. Okay, the second phenomenon happens because the light travels in straight line is shadow. You all know what is shadow. This darkened area that is formed behind the object. So, how is the shadow formed? At night, turn off all lights and bring any candle or flashlight. Turn it on and stand in front of it. You will notice that your shadow is formed behind you. That happens because your body is an opaque object, and this opaque object blocks the way of light that propagates or travels in straight line. So that's why the shadow is formed behind the body. From here, if I asked you, give reason, formation of shadow. This phenomenon happens because of what? Yep, because light travels in straight line. Okay, so now I want you to define shadow, or what's meant by shadow. It is a darkened area which is formed as a result of falling the light on an opaque object. So, if I asked you, write a scientific term, it's a darkened area which is formed as a result of falling the light on an opaque object. So the answer would be, of course, shadow. Super. Now, I want you to try something else by using your flashlight during night. Now, get close to the source of light and notice the size of your shadow behind you. Then move backward for a few steps and notice the size of the shadow. The more you approach from the light, the bigger shadow is formed, and the more you long way from the light, the smaller shadow is formed. Okay, we have talked about the first and second properties of the light. Now we're gonna talk about number 3, light reflection. The third property we have is light reflection. Maybe we have talked about reflection before, and we said that reflection means bouncing the light back or returning the light back. So if I want to define what the meaning of light reflection, it's the bouncing of light rays when they fall on a reflecting surface. And reflecting surface here means the object. It means when the light falls on any object, it will bounce or return back or reflect. So, what's meant by light reflection? It's bouncing of light rays when they fall on a reflecting surface. Okay, so write a scientific term, bouncing of light rays when they fall on a reflecting surface. So this is what, amazing, this is light reflection. So you can see the reflection of mountains on the water in front of you in this picture. Okay, we have a special type or a special kind of reflection called regular reflection. Okay, regular reflection. What's the meaning of regular reflection? It's a type of reflection happens when the light rays fall on smooth surface like a mirror or a water or a surface of the water. Okay, what happens when the light rays falls on smooth surface like a mirror? It's reflected back in one direction, causing formation of your image on the mirror, like this picture in front of you. So, what is the regular reflection? Regular reflection happens when the light falls on a smooth surface and reflected back in one direction, causing formation of your image on the mirror. So when I ask you, give reason, seeing your picture on a plain mirror, so that's happened because of regular reflection. Okay, when you look at the paper, you can see your picture. Of course, no. Why? What do you see? Why we cannot see our image on the paper? Because paper, it's not a small surface. That's why there is no image will be formed on it. I hope you got this part, and I'll see you next time.